Right, so welcome back, everyone. This morning, we're going to be talking about some of the Highwall Miner and production calculations for the Bluefield State University MIET 312 surface mining class project. You join me in my apartment where they are completely deconstructing apartment below me. So you might hear some banging around, some flooring being installed, some excessive grinding, at least in my opinion. I put flooring down before, and I don't remember ever grinding this much in my entire life. But anywho, we're going to plow through it though, because we need to cover this and get this up online so that we can, continue with our surface mine project design for this class. So jumping right into it, this is kind of where we stopped last time. We laid out the new contour strip and all of that. We put in our road, we calculated our volumes, and determined how much, what size fill we're going to need. But in here, for the Highwall Mining portion of this, we're looking at this map, and what we need to be looking at is, let's get this laser pointer turned on. But we need to be looking at what our high wall is going to look like, where we're going to be putting our, our high wall miner projections at, and what sort of depth of cover we might be running into. In the Northern Reserve, you can put in fairly long holes here, and 1,000 feet, maybe even 1,200 in this area, and you will get a depth of cover that's a maximum of about 240 feet. It's slightly less down here in the Southern Reserve, but you'll see in the ARMPS Highwall Miner calculations, at least the method that I use for this, you'll see that there's not a whole lot of difference in what the web pillar thickness is going to be. And let's just get into that pretty much straight away here. I input the following parameters about the extraction height. My sort of assumption here is that it's going to be difficult to completely stay in seam at 3 feet thick. It might be possible, but it has a lot to do with how the seam dips, if there's any rolls in the seam, that sort of thing. That can very much impact your hole depth, and because you have this train of cars behind you, right? How well you're going to be able to stay in seam. And so for this, I assumed that we're not going to be able to stay in seam, and that we're going to have to mine it about 4 feet high. For that, I put in the maximum depth of cover, 240 feet, 11.5 foot hole width, and a 5 foot web thickness on the pillar with a 17-foot barrier and 12 holes between barriers. I chose this because that is the panel width that does not exceed 200 feet, and we can use a stability factor of 1.3 for the web pillars. That's why I chose this. You could do 20 holes if you want. You can do less holes. You can change up the barrier. It could have a better or worse extraction ratio, but it's going to be very similar. And so I picked 12 holes for this. And we get web pillar stability factor 1.33, which exceeds the 1.3 minimum, and a barrier pillar stability factor of 1.5. And given that that barrier pillar has a width to height ratio of greater than 4, a 1.5 is satisfactory for this. Okay, so if we were to have a smaller barrier, you would then need a 2.0 safety factor, right? So in this case, that might even be difficult to achieve, but this is acceptable for for the deepest cover, right? But what about areas where there are lower cover, right? We already have a relatively narrow web pillar width of 5 feet. But we could use all the way down to 4 feet, which gives us that, that width to height ratio of 1, which is sort of a minimum, right? And we could also decrease our barrier pillar to 16 feet, which, is already 17, which is a width to height ratio of 4. And then we could see at what depth of cover, right, this becomes an acceptable design, okay? And in this case, it's about 180 feet of cover that gives us web pillar stability factors of 1.35 and very good barrier pillar safety factors of above a 2, right? So we can use this design, right, for areas where the depth of cover is a bit shallower. So only certain parts of the mine, have to have the 5-foot webs. And so what's this going to look like? When I started putting in the Highwall Miner projections in this area, I had originally stated that I would start here by, shooting this point off and getting started mining in here as, we access the property, right? So with that, I went ahead and immediately put in as many 1,000-foot long holes as I could. There's good reason for this, okay? When you get the Highwall Miner started, you want it to run, right? You want it to run as much as possible. And to do that, to get into these 1,000-foot holes right off the bat is a very good idea. And that it also allows you more time to start getting the strip opened up in whichever direction you decide to go first. I chose going right and showing some, coming around this sort of turn here and starting with shallower holes and then working our way up to longer holes. It's interesting, you could mine some of this in this direction if you wanted to. Instead, I showed it coming around the back. This is also going to be pretty problematic when you're mining, right? If you completely contour all of this, there's a lot of high wall here where you're not putting in high wall miner holes. You could, I guess, put in a bunch of short holes if you wanted to, but I didn't think that was very effective. So you end up with some goofy looking things sometimes, where I put holes in coming back this way, to try and, access at least a portion of this reserve, right? That we wouldn't otherwise be able to get. Maybe you could just chill out for a while and the price of coal might go up and your, maximum allowable stripping ratio does too. And you can just take this whole thing off, right? And then you've got, plenty of room to start working the miner. But in this case, this is how I showed it laid out. You would then, obviously, I didn't do the whole thing. You would continue. At this point, these 1,000-foot holes do reach the outcrop over here. And then, of course, you've got the property boundary at some point. But this is what, the start of this layout would look like and how it's going to continue, right? It's also going to get really goofy in the south too, right? So there's actually not a whole lot of area here to mine. This is a relatively narrow when you get finished up with it. And so what I tried to do was, once you get started, I was trying to get as many holes as I could in that are really long, so that you can get some, high wall opened up, so that you can keep mining, right? So I showed coming right here to this corner, and what you would do is kind of just blast you a face here and then I'm putting the holes in 1,000 feet long right along the property line and put in, maybe 3 or 4 there to get you a couple days to get out ahead, and then start out with some short holes this way. You could come down here to the southern end and mine back up this way and not sterilize this piece of reserve here. However, you're not likely going to do that, because otherwise you're going to have to, either idle the Highwall miner, or, I mean, if you're leasing it, maybe even bring it back later, because it's going to take you time to get around here. And instead, what you're likely to do is just start shooting your holes off this way. That way, you're keeping the miner in the coal, continuing around this side. You're probably not going to need to mine from both sides because this is so narrow. And so basically, once you get around to here, you're done. That sort of thing. There is a little bit that you can get on the other side. Yeah, here. So there's not much space here. Once you fully strip this, there's just not a lot of coal left in here. And so what you'd probably end up doing is bringing the Highwall miner on this face and putting your holes in this way, just to get what you can of it and then be done with it. Okay. So remember we talked about, this Highwall miner production is going to sort of dictate, how fast we have to mine this reserve, how much overburden we have to remove per day to stay in advance. And you have to keep 100 feet of exposed highwall on both sides of the hole that you're currently mining. And that's for observation of the highwall, right? That's to allow you to have space to observe how the highwall is behaving. In fact, it's even better to have more space than that if you can, right? But you do have to balance that with, your reclamation plan and, where you have to store your material, how far you're hauling. You have to balance those things. But in this project, we said that we're going to mine 4 holes a day. I have 12 holes planned per panel with a barrier. We can easily calculate how wide that is. 12 times 16.5. I went ahead and just used the wider web pillar, the wider barrier of 17 feet. We have to add on 11.5 feet because those are center to center distances. And we get 226.5, right? And at 4 holes a day, we divide that by 3, and we're looking at about 75.5 feet. I also added in a factor of a third to account for portions of the bench that you have to mine where you're not going to be operating the highwall miner. And we get about 100 feet of bench that we have to advance daily to stay ahead, right? So in the north, we have to remove about 2 million bank cubic yards. That total length of that bench is 8,200 feet. So we're actually going to be mining this really fast, right? It seems that way. And so we're looking at, we take that 2 million bank cubic yards, and this was what we calculated in the previous lecture. We divide that by 8,200 feet and multiply by 100, and you're looking at about 24,500 bank cubic yards, right? And then taking into account the swell factor, that's about 30,500 loose cubic yards per day that have to be moved, right? And so what about for the Southern Reserve? We had about 5 million yards there. The length of that bench was almost 11,000 feet, right? We do the same calculation again, and we get that we need to remove about 46,000 bank cubic yards a day, or 57,500, right? Loose cubic yards. We need to move that, per day to highwall mine 4 holes a day. That's probably a bit fast, honestly. In good conditions, you can do 4 holes a day. With 1,000-foot holes, you're probably more likely to be in like the 2 holes per day. But a lot of the holes that are projected on this property are shorter, right? So you get more of those, but you get diminishing returns because you have the move time. The move time's the same no matter how long the hole is. So you get diminishing returns on short holes. And so, yeah. But to keep up at this sort of maximum rate, we need to move a lot of material. And so what size shovel do we need? Well, here's how it goes, right? So I took the bigger number, the Southern Reserve, which is a whole lot more than the North, and assumed an 85% availability. So 24 hours of production, 6 days a week, but with a 85% availability, that equates to about 20 hours of actual digging time, right? And we know our loose cubic yards a day. That can get us into we can convert that 20 hours to minutes, right? And we can get that down to 48 loose yards a minute with a 30-second cycle time. Okay, that's 24 loose yards per cycle. And then if we assume this sort of like 0.8 to 0.9 fill factor, you're looking at a 26 to 28 cubic yard bucket. And that would be a Cat 6040 or similarly sized shovel from another manufacturer. And this is a pretty large piece of equipment. It's not the biggest hydraulic excavator that Cat makes, but it is pretty large, okay? And it pass matches, as you can see in the photo, 785s and the next size up. I don't remember which one that is, but this is pretty big. And so because our bench width, our maximum bench width is like 120 feet, that piece of equipment is probably going to end up being too big. And you'll probably end up going with a 60-30 or equivalent size. And with the same fill factor, that has about an 18 to a 20 yard bucket. So this is much more likely what you're going to use because of the bench restrictions, right? So you're going to be, in this case, a bit oversized for the Northern Reserve and kind of undersized for the Southern Reserve, based on the that Highwall miner production rate. However, that'll pass match at 777 or 785. So it's the next size down truck, and this is a pretty common size for a large contour in Central App or Southern West Virginia. And like I said, I was trying to get into in the previous slide before I mentioned the truck match. What I was trying to get to was that this will probably still work out, right? And one of the reasons is because a lot of the Southern Reserve is not going to be highwall mined. And what you'll then be able to do is the rest of the mining will be, you can control it with scheduling, right? So you want the highwall miner to run as much as possible. However, there are instances where it might have to be idle for a period of days to get enough space opened up. But at the same time, your equipment will at least fit in the area that you're trying to mine, or at least should be able to. So that concludes this part of the presentation, or for the project, which included the Highwall mining and some of the production calculations and shovel sizing, right? And truck sizing as well, because we've done the calculations on on shovel and truck sizing, but let's face it, you can just, the manufacturer will tell you, exactly what you need. So, with that, we were basing our calculations on basically trying to keep that highwall miners available as possible, right? And with that, we also have the constraints of the bench dimensions for the equipment sizing, and that both has to be taken into account. So with that, we'll see you next time, and